The sky erupts with anticipation as a gleaming new aircraft takes flight for the first time, marking the dawn of a technological marvel. Engineers on the ground hold their breath, eyes glued to screens as real-time data streams in from the plane's maiden voyage. Every sensor, every gauge tells a story, painting a digital picture of the aircraft's performance in its first dance with the clouds. As the plane touches down, a flurry of activity begins. Teams rushing to analyze the treasure trove of information gathered during flight. Artificial intelligence springs into action, sifting through mountains of data at lightning speed, searching for patterns human eyes might miss. Meanwhile, test pilots step out of the cockpit, their adrenaline still pumping, ready to share their first-hand experiences of the aircraft's behavior. Engineers huddle around computers, comparing the real-world data with their carefully crafted simulations, looking for any discrepancies. AI algorithms work tirelessly in the background, highlighting areas where the plane's performance differed from expectations. The engineering team pores over these insights, identifying specific systems that may need fine-tuning for optimal performance. Flight control parameters are adjusted with surgical precision based on the wealth of data and AI-driven recommendations. Each tweak aims to enhance the aircraft's safety and efficiency, bringing it one step closer to perfection in the skies. Maintenance crews spring into action, developing comprehensive inspection schedules focused on components that showed signs of stress. Safety certification teams begin their meticulous review process, incorporating the fresh data from the test flight into their assessments. Advanced AI models crunch numbers, predicting how different parts of the aircraft might wear over time, revolutionizing maintenance forecasts. Engine performance data is scrutinized, with engineers seeking the perfect balance between raw power and fuel efficiency. The prototype aircraft, still warm from its first flight, receives its first round of software updates based on the test results. Hardware modifications are planned and executed, addressing any physical issues identified during the inaugural flight. As the aircraft evolves, flight simulators are updated with real flight data, ensuring pilots can train in the most realistic conditions possible. Regulatory authorities begin their formal certification processes, poring over every detail of the test flight reports. The supply chain kicks into high gear, preparing for potential scale-up with refined specifications based on real-world performance. AI systems analyze production plans, forecasting potential bottlenecks and suggesting optimizations to streamline manufacturing. Pilot training programs are updated to incorporate the unique handling characteristics observed during the test flight. Teams schedule second and third flight tests, eager to validate the improvements made based on the initial data. Before these flights take place, AI-driven simulations rigorously test each modification, ensuring safety and performance gains. Every decision about the aircraft's final configuration is now driven by hard data, leaving no room for guesswork. As the testing progresses, the aircraft clears certification milestones one by one, inching closer to commercial readiness. The manufacturing process undergoes continuous refinement, adapting to the evolving design and preparing for full-scale production. Marketing teams begin crafting compelling narratives, highlighting the aircraft's proven performance for potential customers. Plans for the full-scale production launch are meticulously laid out, with AI assisting and optimizing every aspect of the process. The aviation world buzzes with excitement as news of the successful first flight spreads, igniting imaginations worldwide. Behind the scenes, engineers work tirelessly to analyze every aspect of the flight data, leaving no stone unturned. AI algorithms detect subtle anomalies in the telemetry, flagging potential issues for human experts to investigate further. Test pilots gather in debriefing rooms, sharing their observations on the aircraft's handling characteristics and overall feel. Their insights provide crucial context to the raw data, helping engineers understand the human element of flight performance. Simulation experts compare the actual flight path with predicted models, fine-tuning their algorithms for even greater accuracy. AI-powered analysis tools highlight specific subsystems that perform differently than expected, prioritizing areas for improvement. Engineers dive deep into these findings, brainstorming innovative solutions to enhance the aircraft's capabilities. Flight control systems receive their first round of adjustments, with each parameter carefully tuned based on real-world performance. Maintenance teams develop detailed inspection protocols, focusing on areas that showed unexpected wear during the test flight. Safety experts begin the painstaking process of validating each system against stringent certification requirements. AI models simulate thousands of flight hours, predicting potential long-term issues and informing future maintenance schedules. Engine performance data is scrutinized, with engineers seeking the perfect balance between power, efficiency, and reliability. Software engineers work around the clock, implementing updates to optimize the aircraft's onboard systems based on test results. Hardware modifications are carefully planned, addressing any physical limitations identified during the inaugural flight. As the prototype evolves, flight simulator software is updated to reflect the aircraft's true behavior, ensuring accurate pilot training. Regulatory bodies begin their thorough review process, examining every aspect of the test flight data and subsequent analysis. The supply chain prepares for potential changes, with suppliers standing ready to adapt components based on performance feedback. AI systems analyze the entire production process, identifying potential bottlenecks and suggesting optimizations for efficiency. Pilot training curricula are updated to incorporate the unique handling characteristics observed during the test flight. Flight test teams prepare for the next round of trials, eager to validate the improvements made based on initial findings. Before takeoff, AI-powered simulations rigorously test each modification, ensuring safety and performance enhancements. Every decision about the aircraft's final design is now backed by solid data, leaving no room for uncertainty. The aircraft steadily progresses through its certification journey, clearing regulatory hurdles with each successful test. Manufacturing processes are continuously refined, adapting to design changes and preparing for eventual mass production. Marketing teams craft compelling stories, showcasing the aircraft's proven performance to potential airline customers. Production planners leverage AI insights to optimize the manufacturing ramp, ensuring a smooth transition to full-scale output. As the aircraft's development progresses, each test flight brings new data, new challenges, and new opportunities for innovation. Engineers and AI systems work in harmony, pushing the boundaries of aviation technology with every iteration. The dream of a safer, more efficient aircraft inches closer to reality with each data point analyzed and each improvement implemented. From the first flight to final certification, it's a journey of constant learning, adaptation, and technological advancement. The aviation industry watches with bated breath as this new aircraft takes shape, promising to redefine the future of air travel. Behind every successful flight is a dedicated team of humans and AI, working tirelessly to perfect every aspect of the aircraft. As test flights continue, each landing brings a wealth of new information, driving the relentless pursuit of aviation excellence. The aircraft evolves with each passing day, its performance honed by the combined power of human ingenuity and artificial intelligence. From the cockpit to the factory floor, every aspect of the aircraft's development is shaped by the insights gained from its first flight. As the final tests approach, excitement builds for the moment when this marvel of modern engineering takes to the skies commercially. The journey from first flight to certified aircraft is a testament to human perseverance and the transformative power of technology. With each milestone achieved, the aircraft moves closer to its ultimate goal, revolutionizing air travel for generations to come. The story of this aircraft's development is far from over as it continues to push the boundaries of what's possible in aviation. From concept to reality, the creation of a new aircraft is a symphony of science, engineering, and human determination. As we wrap up this incredible journey, remember to like, subscribe, and comment to stay updated on the latest in aviation innovation.